here we are doing number 19 on page 638. We have done number 19, number 21, and number 17 today. Just to give you a sample of all the different types, this is the one where the ellipse is going to be turned this way. So this thing is going to be egg-shaped, standing on its end. Let me show you how all this plays out. We're going to find the center first. This is always the first thing. Your goal is to find the center, the foci, and the vertices. We're going to put all this on there. You can see it. You can watch this over and over and over and over until you are a ninja master at it. Okay, the center, -2, +1. You change the signs there. This is -2 and +1. This is HK. And I'm going to plot this point. -2, +1, boom, right there. Okay, now I have to be careful where I'm labeling this stuff, but I'm going to let the center be a red dot. Next thing I'm going to do, I'm going to find A and B. This first one is in fact A, and the square root of 1 is in fact 1. What would B be? 2. Good. 2. So A is 1, B is 2. So watch. The way you plot these points, and I'll tell you what, I did this in the other class and it worked great. A is 1, B is 2. I'll let A be bright blue dots, and B will use a different color. So we're going to go over to the right 1, right there, and over here 1. And we're going to label these two things. This is point -1, 1. This would be -3, 1. Yeah. And of course the circle is negative, or the center is -2, 1. And for this we'll use pink dots for the B. So for the B we will go up 2 to here, 2 from the center, and down 2 from the center here. Again, that's 1, 2 up, and 1, 2 down, and we'll label these. This point here would be -2, 3, and this would be -1. I'm sorry, -2, -1. It's been a long day. That's right. That was the longest 2 seconds ever. -2, -1. And we're going to make our ellipse fit right on there. Hopefully this to be red. Watch this crap. And we'll put that on there. Boom. Just like that. Now what's going to make this tricky is doing the inside of this. Okay? So I might have to do a little bit different kind of triangle on this for the center. So now we have our vertices. Yes, we do. We have all 4 of the vertices. We can fill this column here in. This will be -2. Let's undo that. -2, 3, -3, 1, -1, 1, -2, 1. For the foci this time is going to be up here, which I'm going to represent with a green dot. Right there. That's hard to see. Let's use a black dot right there. That's going to be our foci, because the focus is always on the major axis, which is a longer one. Well, this thing is longer up and down than it is sideways. So for my triangle, if I zoom in, this thing is not going to go the way I want it to. So I will redraw this over here like so. This is going to be basically here and up to here and over this way. Just bear with me a sec. Okay. So how far is it from here over to this dot? That would be, of course, from here to here, and that would be 1 unit. To go all the way to the top, that's from here all the way up to here, that would be 2 units. Well, since our focus is right in here somewhere, and we connect this dot perfectly straight to this thing here, how far would this blue line right there be? that would be 2 units long, because that's the same as that semi-major axis right there. What we want to know is how far is it right there, and we call that C. Okay, so this distance right here is called C. This is, of course, equal to B, and this equals A. So this would also be B, and we're trying to find this C here. So the Pythagorean theorem works out to be A squared plus C squared equals B squared, which is different than the other one. And if we plug everything in here, this is going to be 1 squared plus C squared, which we don't know, equals 2 squared. And we're just going to work this algebra here real fast. This is going to be 1 squared plus C squared equals 4. I should have made that 1. All right, then we'll subtract 1. That's 1 right there. And C squared will equal 3. So C equals the square root of 3. Okay, so that's the distance of this line right here. This is actually radical 3 right there. So that distance from here to here is radical 3. The coordinates of the foci, rather, you use this equation here for ellipses turned up right like this. So it's going to be h comma k minus, or k plus or minus c. And our c is, of course, radical 3. Now, a lot of people will stop right here and say, oh, yeah, my answer is radical 3, and not finish it. To finish it, you come up here and you say h, which is the center, so that's negative 2, thank you, comma, k, which is it is 1 plus or minus radical 3. Negative 2, comma, 1 plus or minus radical 3. That is number 19. And thanks for listening. I'll talk to you later.